Hello everyone. So this video is going to be covering Dr. Chrisman's lecture on connective tissues. Now his lectures are essentially just outlines taken directly from the Gartner and Hyatt textbook on histology. So what I've done is taken the outline and given it a bit more organization than it already had for those of you who aren't necessarily good with just learning from straight up text. Now obviously this video can't cover everything in the lecture, so I've just sort of provided a skeleton for you that you can work from, and if you want you can, put it on a whiteboard and fill it out yourself. And I'm also going to make this whole entire PDF available to you on Blackboard as well. So I've made this concept map with a program on a website known as coggle.it, and it's a really great resource if you're looking to make mind maps like this. And I can actually make it so that you can collaborate with other students, and that way everyone can sort of build a mind map around one lecture at a time, or you can assign people on different mind maps. So it's a really wonderful resource, and I really recommend it. Without further ado, let's cover connective tissues. Now, first things first, we want to just cover the functions of connective tissues. And there's several different functions. First is that it gives mechanical support, so structural support to organs and connective tissue, as well as providing, like it sort of acts as packing material. But since bones and cartilage also fit under the category of connective tissue, that means it's also the more rigid support as well for our skeleton. It provides mechanical protection, so whether that's, bony protection from our rib cage or something like that, but also it provides cushioning with fat pads. And these fat pads can also, fat is used as an energy storage, but it also, since it's insulating, it provides temperature regulation as well. It can provide metabolic support because all of the different metabolites in our body have to pass through our blood. So that means that it's inherently tied to metabolic support. It's involved with the transport of materials because everything either has to go through our blood or our lymphatics to get from point A to point B in our body, and both blood and lymphatics are considered part of connective tissues. It protects against infection because not only does it provide the macrophages, which helps to phagocytize invading agents, but it also provides mechanical barriers which prevent the spread of infection. And finally, it will repair itself after injury, which is where we get our scars from. So now we've covered function, let's cover the different main types of connective tissue. First, there's embryonic, which is made up of mucoid tissue, which comes from the umbilical cord, and mesenchymal tissue, which comes from the embryo and fetus. Next, we'll go over specialized connective tissue, and specialized connective tissue involves blood, cartilage, and bone. Finally, there's connective tissue proper, and this is obviously a larger category here. Connective tissue proper is made up of adipose tissue, which makes up the omentum or subcutaneous fat, reticular tissue, which includes lymphatics and bone marrow, loose areolar connective tissue, which is going to be surrounding most of our organs and blood vessels, and then finally the dense connective tissue, which breaks down further into dense irregular or dense regular. Now, dense irregular is what makes up our dermis, our organ capsules, and our periosteum and perichondrium, while dense regular tissue breaks down into two further categories of collagenous, like things like tendons and ligaments, and then also elastic, which are things like the nuchal ligament and the ligamentum flava. So these are the three main types of connective tissue. But now let's cover what connective tissue is actually made of. So there's two main distinctions for what composes connective tissue. First, there's cells, and then there's everything outside the cells. So let's look at the extracellular matrix first, or everything outside the cells. So what's outside the cells is going to be extracellular fibers and ground substance. Now, ground substance is just an amorphous material. It's largely just water, which is essentially interstitial fluid, but it also contains proteoglycans and glycoproteins. Extracellular fibers, on the other hand, have three different types of fibers. Collagen fibers exist for giving strength extracellularly. Elastic fibers are for stretch and flexibility, while reticular fibers are for more delicate support. Finally, we can discuss the different cell types we find in our connective tissue. Now, these cell types break down even into further groups. There's first fixed cells, wandering cells, and associated cells. Now, fixed cells are what we generally think of when we think of cells. So they're just sort of stationary cells found in our body. So there's adipose cells, reticular cells, chondrocytes, fibrocytes, blood cells, osteocytes, and mesenchymal cells. And adipose cells break down further into brown adipocytes and white adipocytes. Now, wandering cells are going to be things that are moving around throughout our body with different tasks. So plasma cells, macrophages, and mast cells. So like macrophages are going to be moving around throughout our body looking for things to munch down on. And finally, there's associated cells, which are going to be your endothelial cells, your smooth muscle cells, and your pericytes. And all of this makes up our connective tissues. So again, I'm going to be providing this PDF to you on Blackboard, and if you guys are interested, we can get you a link to the coggle as well so you can build one of these yourself.